Welcome again. Today we consider topic 4.3.3. State and explain the criteria used to design protected areas. A NASA image of the island of Madagascar. Perhaps the haven of the most unique biodiversity on planet Earth. Sadly, 95% of this fabulous island has been deforested, leaving, as you can see, a slither of green along its east coast. Many areas within this east coast have now been designated as protected areas, perhaps a case of too little, too late. Perhaps it might have been ideal to designate the entire of Madagascar as a protected area some 200 years ago, and not allow any significant human development. But human development and man's use of the environment is not something that we can stop at our whim. This topic, however, looks simply at the specifications required in the design of a protected area and puts aside for the time being the real socioeconomic issues which dictate whether or not an area can be protected and how well it can be protected. So topic 4.3.3 is focused mainly on the specs, if you like, the design criteria for protected areas. And specs is a very appropriate acronym for remembering some of the key criteria required in the design of protected areas. Size, proximity, edge effects, corridors, and shape are all interrelated in designing a protected area. How big should a protected area be? Should we allow fragmentation of the protected area? Does it matter if it's one big area or 6 smaller areas of the same size? Does it matter if the protected area is circular in shape or oblong in shape, like a square or a rectangle? If there is fragmentation within the protected area, like 6 blocks, do these areas need to be connected? How far should these isolated pockets be from each other? These are what constitute the design criteria. Size, how big should the protected area be? Ideally, the bigger, the better. But, as is the case with the island of Madagascar, size is not something that can be arbitrarily determined. Sometimes size is limited because of human intervention or simply because of a small space. But where possible, the bigger the protected area, the better it is. In cases where it's difficult to have one large protected area because of fragmentation of the habitat, fragmentation of the kind that's occurring in Amazonia, for example, where the large expanse of tropical rainforest is being cut into smaller fragments as a result of things like logging. In cases where it's difficult to maintain a large size for the protected area, it's important that the fragments are in fairly close proximity to each other. And in being in close proximity, It allows for wildlife, like birds, to easily move between one fragment and the next. And in cases where wildlife migrates over land, like in the case of the giant panda in China that needs to migrate from areas of bamboo to other areas of bamboo, needing such a large volume of this specific food on a regular basis. In cases like those, it's essential that the fragmented areas are connected by corridors to allow for the passage of wildlife from one area to the next. So size is an important criteria. The bigger, the more biodiversity, the more mixing within the population. But in many cases, fragmentation is unavoidable due to the challenges of managing protection of the environment with human development. Given the inevitable habitat fragmentation that does occur, it's important to have protected areas within close proximity of each other and to have corridors established to allow for the passage of wildlife from one protected area to another. In effect, fragmented areas become islands within a country or region, and these fragments are prone to becoming less diverse as gene pools are separated from each other. And the greater that this separation is in areas where proximity lacks and where habitat corridors are lacking, the greater will become the isolation of gene pools and the loss of diversity within populations. Habitat fragmentation can be mitigated, as this picture shows, by setting up corridors. A passage is built to connect one area to another and does not allow the freeway to interfere with the wildlife. These wildlife corridors, as they're called, are just an attempt to allow for the passage of wildlife from one fragmented area to another. Apart from the size of the area, the shape of the area also presents an issue. The island of Madagascar provides us with an excellent example. With its 95% deforestation, what's left is a long slither of rainforest on its east coast. Ideally, a large chunk of similar size in the middle may have been better. In this case, even though the area might be the same, what happens is that a large surface on the outside is exposed to the changed environment, and where this border exists, biodiversity changes. In addition, the core of the habitat, the central region, which harbors very unique species adapted to certain conditions of temperature, rainfall, and humidity in the core of the rainforest, they are likely to come under threat. And while the edge may in fact harbor more biodiversity than a compact area, this biodiversity may be less unique than the biodiversity that would be harbored within the core of the rainforest. Species which require specific abiotic conditions are likely to be threatened. This picture here of a road going through a rainforest reserve on the Caribbean island of Tobago provides an excellent picture of the edge effect, where you can see, due to greater light penetration, changes in the temperature and the amount of moisture in the soil has led to a completely different kind of vegetation on the edges of the habitat. And a closer look would reveal that the dense undergrowth of the rainforest core, with its high humidity and low light levels, those conditions are very different on the edge, and it leads to a different kind of biodiversity and a loss of the endemic biota. It's important to remember the specs, or the size, the proximity, the edge effects, the corridors, and the shape. These designs are simply that, and many areas that are threatened cannot be managed according to these ideal specifications, for there are other social and economic issues to consider. In addition, these specs were designed with rainforests in mind, and in the management of marine protected areas, for example, some modification of these specifications are obviously required.